Hello everyone, welcome to Shop Dev. So in this video we are going to have a look at the lazy initialization in C#. So let's begin with our classic introduction of the subject. So lazy initialization is also termed as lazy instantiation. Okay, so what the concept is about is to instantiate an object until it is first used in an application. Okay, and the purpose of it is firstly performance improvement, secondly to avoid wasteful computational resources, and thirdly to reduce program memory requirements. Okay, and common scenarios for usage might be like expensive object is to be created and it might not be used. For example, you might have an if condition, for example, to load a list of clients, customers and their orders, but if the condition is not met, no need to load those records from the database, for example. And secondly, you might defer object creation until other expensive operations are completed. Okay, so let's see the syntax and an example. So to define a lazy initialize type of any type, my type for example, we just need to make use of the lazy keyword and the target type within angular brackets. So consider this example. So I'm creating a customer lazily, okay, and notice the parameters, the constructor parameters for the lazy customer. One of the overloads, I can specify a target method, which is a func delegate, to load the customer, which is expensive, and the second parameter is for fetch safety, okay, for concurrent thread access. Okay, and now you have also the default constructor for lazy, where you can omit a method, for example, to load these target objects. But in this case, in this particular scenario, in this example right now, the customers are loaded from this method. Okay, so here I have a customer, okay, which has a property list of orders, and assuming that the list populating the list of orders is a lengthy operation, so I'm just simulating it via this piece of code. But in case you don't need any particular method to load your customers, okay, you can specify a parameterless constructor here. The thing is, if you don't specify a specific method to load your instances or instance, then internally the .NET framework make use of the Activator.CreateInstance reflection method to create a default instance of the customer or the target type here specified in your lazy instantiation. Okay, but if you specify method, the target method will be used. Okay, and now two important properties associated to the lazy keyword is value created and the value. So by default, before instantiation of the target type, is value created is a bool type, returns false. And once you call the value method, okay, so the object is the target type associated to the lazy keyword is instantiated, and if it is associated pointing to a particular method, so this method is called. And once the lazy type is created, the isValueCreated property is set to true. So let's have a look at the demo. So it's the same example. So just to be before proceeding with the run, so just have a look at the customer class. So I have a name property, okay, of that string, and a list of orders. So the orders class is a simple class with just an ID, just to simulate our lazy instantiation. Okay, so customer has only a name and list of orders. Okay, and same example. Okay, so just to show you, so if you go to the definition here, so I'm using a func delegate and is thread safe overload of the constructor and calling this method. So just to make sure how it works. Okay, so here, okay, so first check the is value created. As you can see here, it is false, and when you call the value property of the lazy customer, so it calls the up concerning delegate, and it is instantiated created with a customer. So we should be having a customer. Let us initialize it with test customer as in the codes, and one order with ID 1 like we have in our codes, and we check our is value property, is value created, so it is now set to true. Okay, so that's it for this overload, and now we need to check if in case we have a lazy customer. Okay, so I'm just for the purpose of understanding, confirming if ever we have a parameterless, we don't have a parameterless constructor for the customer. So what is the behavior? So here I'm just going to my customer class, I add a new constructor that takes a list of orders. Okay, and as you know, when you add in .NET Framework, in C#, when you create a parameterless constructor, the default parameterless constructor is no longer generated. Okay, just do a quick build. Okay, and now we should be having an error, a runtime error. Okay, as you can see, when we access the value property, which called the instantiation, so we get a runtime error, so saying that the lazy initialize stack does not have a public parameters constructor. So to resolve such errors, you need to have a default parameterless constructor in your target type. Okay, so let's wrap up. So the key points to remember with lazy initialization is that if a target type is wrapped and does not have a parameterless constructor, so we confirm we get a runtime exception. And if no delegate is passed in the constructor, okay, so internally the Activator.CreateInstance method is called to initialize a new instance of the targeted type that is wrapped with a lazy keyword. So that's it, guys. Simple concept. So make sure you make use of it whenever you have expensive or resource consuming operations that needs to be done. Thank you. If you like the video, please like it and subscribe to my channel. Thank you.